Hello, in this video we're going to talk about the derivation of the new Keynesian Phillips curve associated with the model of Calvo that he presented in 1983. Basically what we have in this model is that a segment of the firms can choose the new level of prices, but the proportion of firms that can choose the new level of prices is random and the proportion is fixed, and this is 1 minus theta. Basically what the firms do is just to minimize this quadratic function where beta is the discount factor, is below 1 and positive, and p star t plus k is the optimal price if the firms can set the prices in every period. So basically what the firms has to do is just derive this loss function with respect to the p bar. So let's see, the first derivative of this function is the following. So here we have the first derivative of the loss function with respect to p bar, and the optimal level is equal to 0. We just write the same equation and we analyze just part of the left hand side, and we know that this is 1 over 1 minus theta beta, and that's because theta and beta are below 1, so that's a positive number. So basically what we have is the final optimal level of price defined by every firm. So let's analyze a little bit this right hand side expression. So we can extend this expression and we will see in a few seconds that part of that is known. Let's see, we know that if we forward one period the expression that we have in the brown box above, we can express exactly the right hand side very similar to the former expression that we have in the blue. So the only difference is that we move the equation from t to t plus 1, and we're not going to multiply now by theta and beta. And if you multiply by theta and beta and just subtract from the former equation, you will get this very big expression. But the interesting part is that if we analyze this difference that is on the right hand side of the equation, that is actually p star. So basically we can write the difference between p and p t plus 1 bar as the following expression. So don't forget this expression that we are going to use in the following seconds. So that's the expression for the optimality of the definition of the optimal level of prices for the firms. Now let's move to the aggregate price level. We know that firms are equals, I mean identical. So in that respect, we know that theta or 1 minus theta are not able to choose or change prices in period t. So in the Calvo model, the aggregate level of prices, PT, is a weighted average between the former price level, PT minus 1, and the new level of prices designed or defined by the firms, that is P bar. So let's decompose the previous equation, and if we move a little bit from t to t plus 1 and apply expectation, we have those two blue equations. But if we remember the optimal level for P bar from firms, and then we can combine those three expressions in the following. And basically what we're doing here is leaving in the left hand side the expected price level, and we're going to do some arithmetics here, subtract this element in the left hand side and also in the right hand side. So that's why we have this expression to the square and the theta times beta, and then we're going to add and subtract on the right hand side this element theta over 1 minus theta times p. So in this case we will see that with a little simplification we have an expression for something that is associated with we need now a new definition, that is inflation. We have inflation at the end of this equation, and on the left hand side the expression is expected inflation, as you can see, right? So we just move inflation to the left, and we arrange the terms. So we end up with the final expression here, that is P star minus PT, that is linked to the output gap. So the final expression for the new Keynesian Phillips curve is that inflation is equal to expected inflation plus something associated with the output gap. Thank you.